Thanks so much, Scott. Thanks for having me. It's 5 a.m. in Melbourne, Australia. So thanks for having me along. This is the worst time zone. So legacy code, finding the fun. So what I gather is that most of this conference is about the hows and the whats, although hang out in the interactive Gather space. There was also talk on career and navigating your path and life and work-life balance. And this talk will be somewhat interactive and will be more into the socio-technical side of things, or to put it in more down-to-earth language, finding the fun. Nowadays, for the last few years, I've been working at Everest Engineering as Director of Coaching and Learning. That's been internally focused to a certain extent, working with people to develop their craft and consulting skills, but also giving workshops, some of which relevant to this audience. Let's get going. So I think that's more than enough introduction about me, but that'll be on you can chase me up on the slides with the links on the slides on LinkedIn, email, and so forth, if you want to. So let's talk about fun in software engineering. This is an exercise I recommend if you've been doing this stuff for a while, a trip down memory lane. This isn't all the programs that I've worked on, but some of the fun ones. Starting when I first taught myself as a teenager how to program, and threw the Pascal book to the side and started on a Dungeons and Dragons character generator, which was fun. And my PhD was mentioned. I did black hole simulation. All of these dates, some of them they take a few years, some programs were quicker. And in '97, I got burnt out in academia, so I said to myself, well, what skills do you have? Well, you can program computers. And the first substantive project I worked on was around casual staff rostering for cinemas. The links are to startups, which are still up if you want to go and check them out. And already mentioned was one I did in 2014 with my wife, who you can see with the pre-MVP, a one-off program for turning Groucho Marx into an image of Groucho Marx into a design for a pixel quilt, which we subsequently commercialized, which was a lot of fun. It did not make us wealthy, but it made us some friends around the world, and it's still up and running. That's Salvador Dali to my right, also designed with the same software, but if you zoom in, you'll see that there are triangles rather than squares. So lots of fun things to do. And when I just look at this trip down memory lane, what I see is a lot of variety in the domains on which I worked in. And so this was, programming was fun to me. Of course, this is through the lens of nostalgia, and there was stress and challenges along the way. But more later in my career, and the timeline overlaps, I found that the jobs often involved working on legacy, starting with I guess my first more senior job in 2004. It was actually around heading up a small software department for a company that made hardware and software for optometry and ophthalmological equipment. And the coolest bit of gear was around 3D eyeball mapping. So it would map the structure of your eyeballs. And often this was used if you'd had failed laser surgery and needed special contact lenses. This was a bit of a nightmare. And I did go and buy Michael Feather's book, Working with Legacy Code, because I was sort of brought in after the genius who made most of the work of the software almost quit. He ended up consulting back to the company, and he said, yeah, there was 1 month to go on the re-platforming from VB5 and 6 languages I refused to work in, or swore I'd never work in again, and C++ onto .NET. So there's an estimated 1 month to go. It took us a year to get there. And when we finally launched, one of the bits of software was like connected to practice management. And of course, it recorded the details of your right and left eyes. And there'd been a database upgrade from all the many previous versions, and it switched the right and left eyeballs. And so that led to one day where the team and I said to the team, we don't leave until this is done. We found it, we fixed it. The execs were not really appreciative of the amazing work of the team, at which point I knew I had to leave for other adventures. But I learned lessons, technical lessons, and lessons about interacting with people in that, and the many subsequent legacy related pieces of work, sometimes programming, often involved in a coaching or leadership way. Too many to recount here, but there are stories from all of them. So let's talk more. So the first question for you, please put answers in the chat. Apparently there's a slight delay, so I'll just keep talking for a while. Is, for you, what makes software development fun, and why does fun matter? So I'm going to leave about a minute. I've got these little fun quotes here, so please use this to reflect. I think in many ways my strengths are as a facilitator, and so I like the interaction. Rather than having dead air, I'll just read the amusing quote. Do what you think is interesting. Do something that you think is fun and worthwhile, because otherwise you won't do it well anyway, from Brian Kernahan, one of the creators of Unix and a great educator in the field.
I did share your question with the audience, and we haven't had any come in yet, but I'll say I can answer it. I find it fun to solve puzzles. I like solving puzzles and kind of almost like the detective work of like finding a problem and where to fix it. So we do have some answers coming in. Somebody says they love seeing something come from their brain onto the screen. Somebody else said that building stuff is fun, solving problems as well. So somebody said puzzle work is different than pure creativity. You have boundaries.
Yeah, that last one is maybe coming ahead to this, the distinction we'll get to between foreshadowing between green fields or purely creative work, or more purely creative work, and what comes up with legacy. Maybe Scott will do this as a bit of discussion or banter between you and me, and you can channel the audience. Now we're going to do a really fun thing of unpacking fun, applying an analytical lens to fun. It's just one lens. I'm going to equate fun with intrinsic motivation coming from the inside, and you could use another lens, but you be the judge of how insightful this is. So we're going to look at autonomy, mastery, and purpose, but also connection, as in human connection. These things come from a field called self-determination theory. They use slightly different names, filtered through Dan Pink, who dropped connection or relatedness in the self-determination theory and added purpose. I think purpose is a good addition, but it's a shame to lose human connection. Your mileage or kilometerage may vary as to which of these motivate you, or even if they add up to fun, but this is the main lens I'll be going with today. So let's start with connection or social belonging. So this isn't always the case in software development, especially if you work solo, and it may not be the case for you, but I found later in my career, I really liked working in a team and pairing and collaborative problem solving. And you get this kind of mind meld effect when you do that as well. So I guess that's an expansion of collaborative problem solving. Autonomy, the rights to make your own decisions, self-agency and so forth. So some freedom to choose approach, tools, etc. Of course, this varies in different places. And trust from colleagues, and there are cross connections here to make technical and business decisions. So that can be good and empowering. Flow state, I wasn't sure where to put that, this sense of being in the zone. And I'd argue it could go in different places, but that can be extraordinarily satisfying and possibly fun. So in the responses, we got quite a few on mastery, like problem solving, learning new things, seeing your code work, that thing of stopping beating your head against the wall and the relief that comes. Clean code, elegant design, these are all marks of mastery, which feature prominently and with good reason. And then purpose, making a difference, making things that change lives in your users or stakeholders or customers, contributing to a larger mission. So I think software development is extraordinary in that you can hit all of these in the ideal state. And that's great. And that makes for fun. So let's switch to legacy code. So what is it? I'll give 7 points of view, some familiar. So legacy code, let's take the safety view. And I think this is Michael Feather's code without tests. Emotional code, I think this is JD Rainsberger, but it could be Dan North. Valuable code that you are afraid to change. And in a sense, there's an argument, maybe not in the most scientific sense or mathematical sense, that these definitions will all overlap or if not be exactly equivalent. So different facets of legacy. Pragmatic code that is hard to change and brittle, hence risky. Commercial code that no longer satisfies user or business needs and is expensive to change. And these last three I'll focus on more in this talk, or these lenses. A systems thinking view that code where the developer's theory of the system, or I think we'd say mental model, has decayed or been lost. Socially code that demoralizes the team when they work with it, so not fun. And because everyone has to talk about AI all the time now, code that AI cannot reliably explain and or change. All of these things might be regarded as facets of legacy code. So my first reflection is, why is some legacy code inevitable? So we're not perfect as programmers or people. We're limited by our current level of skill and knowledge. And so this was this thing over my long and storied career. I've learned stuff and I've gone, if I'd have known that some time ago, I might have done it different or more idiomatically or simply. And I'm sure everyone's the same. You're limited in what you can do at the time. We take shortcuts. I know I do. Over time, we forget. Early decisions live on to haunt us. So this is this idea we may be manufacturing our own legacy. We learn good and disciplined approaches, but they're difficult to sustain. Test-driven development being sort of the exemplar of that. Collaboration helps pairing. We can't predict the future, so priorities change. Tech changes, and so our options change. What was the best option some time ago is no longer the best anymore. I've certainly seen many times there have been like homegrown frameworks, and then some years later an open source or commercial superior alternative appears, but everything's sort of wired in, and so it's a big investment to dig it out again. And our knowledge decays. The original developers leave and their understanding walks out the door, and not all of it is passed on. And there's this distinction between explicit and tacit knowledge. We can't really explain everything or put it into artifacts like documents. And finally, but people probably put this higher up in a commercial sense, there's delivery pressure. Deadlines and market opportunities often take priority. It relates back to why we take shortcuts, not just from us being imperfect, but because of commercial pressures or perceived pressures. So, legacy versus fun. This is from an informal survey by, I'm not sure how to say his name, but I'll guess Ivo Lukács. And do you like working on legacy code? Now, this is the first time I've given this presentation. This may be the audience which is most skewed towards loving it. But for most people, they do not love it. I did a practice at my work, and one of my colleagues said, I don't want to work in COBOL. So that was their interpretation. And then they had to leave, so we didn't get to discuss it further. So interesting, hey? What's up with these people, which may be you? And even if you go, legacy is the best, I've got a consultancy that works in legacy, you're going to run into a lot of people who don't. So next question. What kills the fun when you or your colleagues work with legacy code? I know I didn't love it at the outset. So while you write in the chat, and Scott will be returning, this John Woods, I looked him up, is a games programmer. Always code as if the programmer who ends up maintaining your code will be a violent psychopath who knows where you live. This may be, in my opinion, sage advice, but I think it is very rarely taken advice from my experience.
For
Scott.
me, what kills the fun when I'm working with legacy code is being told that I can't improve it. Right? Like, to me, what makes it fun is the improvement process, right? Like that is I get joy out of making it better. I get joy out of imagining what it could be, and then incrementally taking it there. And when I'm in a team environment where I'm told you can't touch that, that's really hard for me.
So yeah, it's a great example. And using the model I'm using, I'd say, right, that's your autonomy being impinged on. You don't have the autonomy to fix it. I have a quick story about that. When I was one of the legacy areas I worked at a financial institution, every year there was help the accounting department with the tax reports. And it was this awful legacy code. And so one team each year drew the short straw or was given it, and they would have to work with this awful stuff. And it was a very slow loop because it was being manually tested by the accounting department. And I was working closely as a tech coach with one of these teams, and they said, look, pretty much what you said, Scott, this is fine, but we would like to fix it so that next year it's not a problem for the team with the short straw. And so as they were working on it, they were quite motivated to take notes, and they couldn't necessarily fix it all at the time because there was that delivery pressure, but they were ready, given another week or two, to really clean it up and make it a lot better.
Yeah.
And then that was taken away, and it was such a downer. So yeah. Have we got any other ones coming through the chat?
So somebody says, not just being in control of knowledge, but the strong suspicion that you'll never be in control of knowledge, no matter how hard you work at it. Somebody else said, probably the fear of not knowing if your change will break some unknown peace. And then somebody said, not getting enough buy-in from others. So I think
so we're starting to get mastery and connection with that last comment of the buy-in for others. So let's see what Evo got when he did the informal survey. They did. So you can read that yourself. The two I focus on with my training are the two biggest ones. What was mentioned before, fear of breaking something. A lot of the techniques which I think are common in this community, use of golden master and beyond, let's say, to set up safety nets and tests, can take that fear away. But operating without that safety net, very stressful. The spaghetti code, how do you unwind all that? And then a bunch of other things. So there's a lot to get your head around, to be skilled enough to work with it and then make those insightful decisions. I was trying to sort of capture the emotional side, and so there's sort of like this image or some images I came up with. So you've got this metaphor going of these miserable people cleaning up a mess and not enjoying themselves. So that's a kind of a gestalt. I think if we come back to connection, autonomy, mastery, and purpose, the connection and purpose aren't necessarily too bad. You can still be part of a team, problem solve together. The shared mental models might be in desperation, and purpose can be okay as long as you're in a well-managed, well-led organization. Sadly, not always the case. But specific to legacy code, if you don't have the tools for the job, if you don't have command of the techniques, which are very different. I had to learn these along the way, starting with Michael Feathers and Rainsberger and beyond. And I know Nicholas has put together a great toolkit. But if you bumble along without specific tools and skills, it's really hard. You're doing a very manual job. And then your autonomy gets severely curtailed when you're told, like was mentioned just before, you can't touch or you can't improve this. That's a real motivation killer as well. So, a digression, mental models. So I found this terribly insightful. Peter Knorr of Bacchus Knorr form for the computer scientists out there wrote a fabulous paper in 1985, which I discovered much later, Programming as Theory Building. And I think that this is quite profound. So Peter's thesis was that a program is more than its code. It's built on having a theory of the system, or I'll call it shared mental models, or mental model if you're just the first person doing it. So to confidently and competently change code, you need this big picture level of understanding as well as the details. And the easiest way to get that is to write it yourself or be part of that original team. So you're sort of learning by doing, you're building it up, you're having those debates, you know why you did things or in a particular way, rightly or wrongly. And the representations in code, in comments or documentation are always incomplete. It's in people's heads. And even then you can forget it. You know, it's like the joke about what's legacy code. It's what I wrote last week or 3 months ago or 6 months ago, depending on your memory. So when that mental model or mental models are lost or they degrade, the code becomes hard to work with, especially if you're taking shortcuts or being super clever. So once the original developers are gone, this activity of reconstruction becomes a lot like archaeology. It's like this lost civilization. What were they doing? You've only got some of the understanding and you need to rebuild an understanding. Also, I like this. Everyone knows that debugging is twice as hard as writing a program in the first place. And I hate debugging. So if you're as clever as you can be when you write it, how will you ever debug it? So sometimes being clever, this is my experience, you get very clever people together and they try and do hard things and they come up with a clever solution. And then not only is that difficult to debug, it's difficult to change later in the future. So you want to make things as simple as possible, but no simpler, to quote Einstein. Also, I don't have a quote for this, modularity, replaceability. If you can make things smaller, then you don't have to, and not as spaghetti entangled, they're easier to reconstruct that understanding or preserve it. That's, of course, gold. So how do we bring back the fun? So again, answers in the chat. This is probably the audience with the best answers for this one. When I'm working on a problem, I never think about beauty. I think only how to solve the problem. But when I have finished, if the solution is not beautiful, I know it is wrong. So there's sort of this aesthetics dimension. I'm not sure how applicable this is to bringing back fun, but certainly that's there's something there. Scott.
Yeah, I think like when I'm talking to people who don't love it, what I try to advocate for is recognize all the ingenuity that's needed in order to be successful, and that let that be the scope of invention. Let that be the green field that you are playing in, and kind of like restrict your scope to that. So like, you know, kind of like make a decision that like, even though it's old, you're going to work with new tools or new techniques or new approaches, and bridging the gap between the system that you're now a steward of and those new tools is going to require invention in a lot of cases. And so like, let that invention kind of fuel your desire to build something new.
Yeah. This is something that I haven't brought out as well as I plan to in the presentation itself, but I think it's spot on. I think that you can dissolve the distinction, this may be a bit idealistic, between the green fields and the legacy. It's like, well, if the legacy worked well enough and we don't need to change it, then we don't need to do anything. But as soon as you're adding new features, you're bringing back in some sense of green fields, but with the constraints that have been created or made easier in some sense. And on the flip side, if you have great techniques, you can reduce the amount of legacy that you're manufacturing, or the difficulty for to work with it. So yeah, that's great. What have we got from the crowd?
In chat, we have having a wider culture of code standards and having a mentor-driven culture. And then somebody says when they work with legacy code, their goal has turned out to be what can they learn from this so they don't write code in the future that will become legacy code. And then that is part of what makes it fun again, kind of turning it into a learning opportunity.
Brilliant stuff. So I just wanted to, at an emotional level, let's see if I've got this right. You look at the faces and the depression here, right? There's not what we would call pride in work. So it hits the button. And my reframe was, and I apologize for the war aspects. Like, it's like being part of the special forces who are trained, who have the tools and have the skill, and a certain amount of status and recognition for coming in and doing a difficult but valuable job. And this can be sort of an internal reframing of attitude, but also how you're valued more socially. So I think we said before that connection and purpose were okay. The bit that I'd bring out using this lens is mastery. You need to learn the skills for to work with legacy. It's harder because of all those constraints and difficulty and the rebuilding of the mental models. But once you've got skills and techniques, and this goes back to the flow thing, that if a job or a task is beyond your capability, it's not going to be fun. And if it's super easy, then it's not going to be fun. So there's this sort of sweet spot of being up for the challenge, recognizing it as something worth doing, which comes back to purpose, and maybe doing it socially and with your crack team, but also having the level of skills that you've got this. And once you've got it, then you can put together a particular strategy and deploy those advanced skills. Without that, what I see is like this road to nowhere. So yeah, so in valuing the work and getting the skills and putting it all together, we want to go from this picture on the left, which is more of a sort of a victim mentality of, oh, poor us, to more of a heroic mentality. Maybe that's making too much of it. But since I want to make the talk fun, I went further and did a Greek myth edition. So we've got the myth of Sisyphus, whose punishment was to push this boulder uphill. Or I think he crossed Zeus. And then at the end of the day, the boulder would roll down again. You have to start pushing it up again. And I've certainly seen seemingly endless legacy projects which don't finish. And then you end up with the old code and the new code, and it's a mishmash, and the complexity is increased. That's terrible. So what's the opposite of the myth of Sisyphus? The best I could find with some help was Theseus, who was able to, where others failed. I think this is, I haven't thought too much about it yet. It's a new one for me. Into the maze, which represents our complexity of legacy, where the Minotaur dwelled. And he was able to slay the Minotaur. And how did he not get lost? He had a thread, which is sort of, might even be thought of as our automated tests and other advanced techniques to help him. So we want to go from Sisyphus-like experience to a Theseus-like experience. We're up for the challenge. So what I believe we need to succeed, in my experience, so from overarching leadership, so I'm looking at an organizational context here, we need air cover to do the kind of work that we need to do, and meaningful support and respect for the work. Without some air cover, it's very difficult. And sadly, I think this is too often the case. At a technical leadership level, we've got to get that balance right between, however you're structuring it, between just piling on new stuff, creating more technical debt and difficulty, and undoing, repaying the tech debt, improving things, using the skills to turn legacy into workable stuff again. I want to say a little bit about advanced skills and knowledge. I'll use the yin and the yang. Starting with the yin, the black box approaches. So things like automated tests. So if you don't have automated tests, then there are techniques like Golden Master, design by contract, etc., 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 etc. I'm sure they're being talked about elsewhere to help us. Otherwise, that fear of breaking things, the spaghetti code, it's very hard to address. And the white box approaches, this is the rebuilding of the mental models. This is just so hard, and it takes time to understand what's going on enough to be able to simplify, repair, make it workable, as opposed to copy and pasting and just making the situation worse, or more a bigger and worse ball of mud. And that unwinding of the spaghetti. Okay. And on the ground leadership, so coaching and techniques. So what I've been doing a lot of lately has been running workshops to get people started, and it doesn't teach them everything they need to know, but it sort of tries to get you over that just bumbling along into, hey, this can be challenging and fun with a few of the techniques, but then you've got to learn and work together. So the on-ground leadership is like player coach or tech coaches who can then help lead the way and continue to mentor and help, sound decision making, like as opposed to, no, you can't fix that. So that's what I believe we need. So let's go back and go through the model again a bit more concretely. So in terms of connection, working as a team, or at least in pairs, so that this very difficult task of the archaeological dig, it's a lot to do as one person, especially as our software gets ever more complex and distributed, and using different stacks and so forth. So I guess the opposite of this would be try and divide it up, and each person gets their little piece to decode. But then what happens when they go on holiday or leave? You're losing the knowledge again and again. So building it up at a team level, I think, is important. It also gives you that moral support for the really hard stuff. In autonomy, the team selects and adopts techniques and tools. There's that balance with when you're up at the team of teams level, of course, but some autonomy is good. And leadership providing air cover. So you need that sense of ownership. You need that sense of worthwhile, that this is a heroic task rather than a thankless one. Mastery, I think we've covered, in order to be effective, and purpose. So I think this is where the overarching leadership can help again, that this is valuable, that the work is valued, and it's not that we only value new features, and that connection to whatever is the purpose of your organization, which is hopefully worthy and uplifting. So respect and resourcing. So that's how I think we bring it back. Because AI is everywhere, and I don't even think we've reached the peak of the life cycle. I've been doing some experiments too. Cautiously, I have found it useful to use the LLMs as a creative partner. For instance, that Theseus, I had the myth of Sisyphus, but I didn't have a corresponding Greek myth. So I told it about my problem. I asked for suggestions. It gave me about 5 or 6. I went, Theseus, that's the one. And of course, it helped me make some images. Can be very good for learning. It's read the internet, so it can help. About the code, can it decipher and help and explain code? Somewhat, yeah. Learning advanced techniques. This is a hope of mine. Like, even before I learned test-driven development, I learned this thing called design by contract, which is part of my toolkit. Not very well known, but and there's many others, some of which I've learned to use, some of which I know a bit about, but haven't gone into. I never went as far as formal methods, but I can see that there are people now looking again at more lightweight formal methods and maybe trying to bring down that barrier to learning, because these and other techniques can be really valuable if people will learn to use them. Because I teach test-driven development along with pairing in one of my workshops, I've played around with, as I'm sure many have, with using AI to augment it. And I've come to the conclusion that every part of the TDD cycle can be assisted with AI, but you have to be careful. So brainstorming slices, coming up with tests, coming up with code that passes the test. But the thing you have to do is run them against each other to cross-check, and with refactoring suggestions. So it's a bit of that white box, black box kind of thing. It can be a bit of a strangulation to try and stop the LLMs from running far ahead and just doing a little bit at a time. But then as you build up your regression suite, you can cross-check from a black box point of view, and you can look at it and say, well, do I understand this? It's more the refactoring step. So there's potential there. Like I said, it's read the internet, so it can come up with suggestions, options, and answer questions, and can even do some of the boring bits. But I want that assurance that it's not just hallucinating and breaking things. So concrete things like tests and contracts are really, really good. And modularity. A colleague of mine who's a data scientist and data engineer has pointed out that the cost of running these foundation models goes up quadratically. So if you've got a huge spaghetti code base and you want the AI to fix it, that's going to get very, very expensive. On the other hand, smaller, more modular pieces are easier for the AI, similar to the cognitive load in humans. So, which I guess brings architecture, modularity, and replaceability to the fore in both cases. So, to conclude and leave some time for questions, this is a picture from a legacy code retreat style workshop. So, on my journey from being a software developer and leader to coach and tech coach, I went from working on XP, which had pairing and which some people loved and a lot of people didn't get. And so I'd had one of the startups, we just worked XP and we'd interview people by pair programming and TDDing, and it was great. We had this filter on the door for people who kind of got it or had potential. And then I left and I thought, I'm not sure if I can impose this kind of working on people, but I missed the quality and the camaraderie, the connection, if you like. And then I found code retreats and legacy code retreats, which are dojo style environment. And so I've been using them, not just for teaching TDD, and in legacy code retreat, you do golden master and simple design, but I've thrown other tech skills and connection skills in there as well. And hopefully these people look engaged and having fun. So where to start? Leadership engagement, fun workshops, but I don't think the workshops are enough. You need the technical coaching as well. You can see what kind of workshops I do. Can even do them online, probably in the wrong time zone for many of you, but we can talk about that. In conclusion, legacy code can be fun. I'm sure you all know that. The lens I'm using is that it's the mastery and autonomy are absolutely critical. And once you've got those, then you can understand how long it takes, what it's going to take. You're going to need to keep learning. You're going to need to specialize for the particular context, as is always the case. We need to raise the status of mending work and provide access to whatever you need, and that all-important air cover. I hope this isn't teaching you all to suck eggs, but I think that rebuilding of mental models is really, really important. We'll see in a year or two whether the dream of AI taking that away from us, the dream or the nightmare, is it's true. I'd probably bet against it. I think we still need to understand, and we need all those great techniques which can give us automated feedback. the Gen AI and skill development can help, but it feels like it's really early days. I start with the skill building workshops. I think there's a case for starting with leadership as well. I'll just finish with that Gestalt image, and I would love to hear your comments and questions. That's it.
Nice. Thanks. And while we wait for questions to come in on the chat, I can kick things off by asking one. What do you hope AI is going to be good at? Like if you were to design a positive impact that AI could have on, kind of the challenges that we face with older code bases, like what would you deem as helpful?
That's such a great and a deep question. A little story. Which one shall I choose? I'm going to, one of the later bits I worked on, I had the privilege of working for the Australian federal government for our tax office. And they have many sedimentary layers, to use that archaeology analogy, of legacy. And one thing I'll say is the tax office will never go broke. So it could, they could have outages and so forth. And but and there's probably common with other big systems, like this core bank systems, et cetera. There's just layers of complexity rooted in the real world, in legislation and so forth. And going back to what I said about where legacy comes from, people would have designed it with their best knowledge at the time, and by the sheer longevity of their systems, many of those will have left. And so I certainly met people who were towards the end of their careers, and they were like the last stop, and they would have to try and fix the problems. So I think going back to the white box and understanding things, to actually, if we go from, yay, it works and it kind of does what we need, and maybe we need to patch things all the time manually, to actually being able in the future to understand and simplify systems. And I mean, there's these profound, potentially there are these profound changes, but it seems like, we, even with the great kinds of tools and level of mastery promoted by people like yourself, Scott, and Nicholas, and other luminaries, I think we're striving to survive rather than thrive. And what thriving would mean would be to be able to really simplify and collaborate with our stakeholders to simplify the systems, the businesses, government, organisation, which use these things to make a better impact and do good. So that's ultimately going back to purpose.
All right. So somebody has said top 3 recourses for mastery topics.
There's stuff out there. I'm a bit of an autodidact. I can learn things myself, but I think that a great thing to do is find community and mentors outside your organization if you don't have them inside. So I guess I assume, Scott, that the Mender community, Legacy Code Rocks, or the Mender community, is a kind of world hub for this.
That's my goal. for both people who are looking for help and people who could help. Like, my goal is for it to kind of be, kind of serve that bridge and kind of, create that source of connection and kind of the Mender as a label to kind of create an identity for folks who are in that 5% on that graph. Another question, do you know of any tools specialized to working with legacy code? In the past, they found setting up a testing framework and searching through legacy code to be some of the most difficult tasks when working with legacy applications.
I think, Scott, you're maybe the better one to answer that. I do notice that there are some big plays going on with major companies like Mechanical Orchard, Fortworks, McKinsey, etc., at the bigger end of town. My experience was like, just working with teams to go, the first thing you'll need to do is figure out an appropriate testing framework and figuring out how to do a golden master or property-based testing or what have you. So it's sort of like I would have like patterns or a selection of tools, do some technical strategy analysis, and then like, okay, how do we get set up? What do you think, Scott?
There's some tools that I wish existed. There's a lot of tools that I wish existed. I think the Golden Master approval tests, learning that as a tool is incredibly helpful. One of the things that I wish existed was kind of a more programmatic way to apply those for you. Identify things that could be easily wrapped with such a test, and then write the test for you to wrap it. Like, I don't know that you necessarily even need AI for that. It would be, I think you could write a deterministic program to do that by traversing an AST and kind of building up property-based style tests that are then have a golden master output for certain input categories.
Just to riff on that, I think an interesting use of AI, because like traditionally with property-based tests, it's like, well, how do I think of a property? If you can get a small enough thing, you can ask the AI for suggestions. Maybe that triggers something. Again, that's collaborating, not saying you're handing it over to the thing.
I think automated refactoring tools are a big bonus tool too. So like if that's something you don't have access to, then try to find an automated refactoring tool for the language that you're working with, and the good ones cost money, so be willing to spend money for them, and the ones that do cost money, I'm specifically thinking of the JetBrains and the JetBrains ecosystem. They're worth it. So like try to make the case for your employer to get those tools for you to make it easier for you to do your job.
I think the point I wanted to make on that was the tool. You need a toolkit, and the tools, it's probably implicit in what we're just saying, but the tools can often be used together in different combinations. So I think everything we just talked about, may or may not, any individual tool may or may not be useful in a particular context, but usually if you can pick 2 or 3 of the right ones. I certainly had an experience with the automated refactoring tools with a 5,000 line function. I said, I've got a 5,000 line function. I said, send it to me. A lot of copy and paste. And after we set up our unit tests, we would spend like framework an hour a day, where I'd say just pair after lunch and only redo refactorings which look completely safe. And we thought there wouldn't be much, but actually there was quite a lot, because there were things that were isolated and you could just extract function, wrap a test around it. And of course, using an automated refactoring tool to identify and safely extract the safe ones without, it's a different kind of safety net to what you get from the other tools like tests.
All right, well, we're at time. Dan, I really appreciate you getting up so early or staying up so late, whichever it was the case for you. If you kicked off the event with us, then you've been up for a very long time. Thank you. I do appreciate your time.
Thanks so much for having me, Scott.
Yeah.
And thanks, everyone.